Hi everyone and welcome back to the Multiverse of 100 plus data science project series. In this video, you will learn how to segment a customer using Python and machine learning. In order to do the customer segmentation, you're going to be using a dataset from the Kaggle that's called Mall Customer Segmentation Data. Just sign up with your email account and you can get this kind of pages. So you can just go down and you can selecting your CSV file and you can just clicking on this download button. So let us start by importing some of the important module, just like pandas, numpy, and the matplotlib, just for the data loading, data manipulations, as well as for the data visualizations. So let's import it. Let's import here pandas as pd, then import numpy as np, as well as I'm going to importing here matplotlib.pyplot as plt, as well as I'm going to importing here cborn as sns, and then I'm going to give it here one matplotlib inline so that we can plot it in the Jupyter notebook as well as in the inline format. So let's say matplotlib inline. Shift enter, or you can also clicking this run button as well. So you can see that our model is imported correctly. Pandas, NumPy, Matplotlib, and Seaborn. So now what I can do is simply going to importing our dataset. I mean loading our dataset from our directory. So this is our dataset. It's nothing but called mall underscore customer.csv that we downloaded from the Kaggle. So let's import it. I mean load it. Let's say pd.read underscore csv, and inside that we are going to give it here the name. Let's say mall customer, let's say customers customers dot csv, and also this should be read underscore csv. So let's assign it to a variable called data, and then let's try to see the data.hat. So that's our data set. It's just having the 5 features column. You can see customer id, gender, age, annual income, and the spending scores. Now the question is, what types of machine learning is it? We know that there are 3 types of machine learning are available. One is called the supervised learning, okay, supervised, and another one is called the unsupervised, and last one is called the reinforcement. Just pause the video and answer this one, okay? Is it a supervised, unsupervised, or the reinforcement learning problems? So, well, I hope so you got the answer. Yes, the answer is unsupervised learning. Why? Just because of if you see the data set, we don't have any target column or we don't have any target classes. That's mean we need to segment the customer based on certain data points. That's mean this is one clustering problem or the unsupervised learning problems. Now let's see that correlations between our data sets. So let's say data.core. So this is how we can actually we can divide them in the divide the problem statement in the supervised unsupervised learning problems, okay, based on the target classes. Because in the supervised learning we have the supervisions, and in the unsupervised problem we don't have any supervisions, we don't have any target classes of the scene data, okay. So if I see the correlations of this data, you can see that we just having the 4 column it will taken. So in our data set, we have the 5 column, but it's just taking the 4 column, 4 numerical columns. That's when gender is missing. Except gender, it will taking the numerical columns. Now, what are the correlations? Correlation is nothing but the correlations between the 2 features columns. Between 2 features column, that how it is correlated. If the one value increases, another value is also increases. But if I see that the annual income by the age, it's called negative correlated. That's mean how and the one of the column is increases, another column is decreases. This is how we can do the feature selection, or you can say extraction. I mean feature select the features from here. It's called the feature extraction, not it's called the feature engineering. So you just have the 5 features, so you don't need to do the feature engineering or feature selection here, okay. So what I can do, we can right now we can do the data visualizations in order to getting some information about the data, that how our data is distributed and how our data is look like, and we can get some insight from the data. So we can starting here the data visualization. Let's say data visualization. So first what I can do is simply going to using the distributions of this annual income. So you can giving here on a heading, let's say data analysis, let's say analysis, and you can give it here, let's say hashtag, and then you can simply go into using here the markdowns. So data analysis. So first what I can do is simply going to see the distributions of the annual income, because we just have in the two columns annual income and spending score as well as the age. Customer is nothing but it's mandatory, is then primary key, just like in the SQL. So what I can do is simply going to say that let's say distribution of annual income. Let's say annual, okay, it should be the annual income. Then after that, what I can do, you can comment this out, or you can also do one markdown. So let's go to markdown and let's do it. So now what I can do is simply going to use here plt.figure, and then you can give it here on fixed size. So let's say fixed size, let's say comma 10 comma 6, and then to do the distribution of the annual income, so it's better you can make it small. Markdown, okay, let's do on the code, and let's say we don't need to give it here another one so that it looks small. Okay, or otherwise you can also make it as a just one single line, just as a markdown, because we just have been heading of the data analysis. Okay, so that's the distribution of the annual income. So we just give it the figure size. Now we can simply go into using here sns.set. Let's set on a style, so let's say white grid, so that it look good, because our notebook is also white. So let's say sns dot distplot. So using the distplot, you can do the distributions of the data. So let's say data, and our column is nothing but called annual income. So let's copy this out, and you can simply go into paste it to here inside this quotations. So you can using here on title as well as the X level. So let's say plt dot title, and inside there you can give it here, let's say distribution, let's say distribution of, let's say, annual income, and then you can give it here on X level, let's say X level, and in the X level we have the range of annual income. Okay, so then in the Y level we have the count of that, let's say Y level, so we have the count, so let's say count count. Now any error, so Seaborn has no attribute called figure. Okay, okay, sorry, the problem actually happening, it should be Seaborn as SNS. That's the problem. Okay, that's not a big deal. So we can see the distribution of that, and the distribution is look like that. Most of the value in the graph is located in the 50k to the 75, so it should be 85k. Okay, that's when most of the value is located in the 50k to the 85k regions in the annual incomes. That's when we got some distribution about the annual income. Yes, the most of the income is lies between this 50k to the 85k. Cool. Now let's try to draw the distributions of the age as well. So let's say distribution of age. So what you can do, you can simply going to go on the markdown, and you can simply going to copy this code from here, and instead of the annual income we can just give it to the age. So let's say age, and you can simply going to copy this out of this one, of this one. Okay, fine. And in the case of age, you can see that you have the variety number of ages, and the most one is nothing but 30 to 35 is the peaked one, but it have the variety number of ages, we can see on the graph. Okay, we can see in the graph. And now we can also do the distributions of the spending score as well. So what I can do is simply going to copy this out, and we are going to paste it to here. So paste it to here, and it's better you can also give it here one text. Let's say distribution of spending score. Let's say spend, okay, should be spending score. So you can give it to the markdown, and you can simply get a markdown list. Okay, so we have the spending score, right? This one is spending and score 1 to 100. So we can copy, and you can simply paste it to here. Here you go, and also there and here. So yep, our graph is generated, but if I see the graph, so most of the value is lies between to this 40 to the 60, 40 to the 60. That's mean we see that in the case of annual income, the value is lies between the 50k to the 85k, and here the we have the variety number of values, variety number ages. We cannot lie them, but the 30 to 40 is the most one, peaked one. And in the case of spending score, it lies between the 40 to 60, the most hyped one. So you see that in our data sets. Now let's try to see that how many gender we have. Okay, in some kind of data set it have the male, female, and others. So let's have a check that how many classes we have inside our gender classes. So we can simply going to taking some shell, and let's say gender. Okay, genders equal to, let's say, data. We can using here this one as well. So let's say gender, or otherwise we can also using here data dot gender, like that. You're just getting here an instance of this gender, so that's why you can also using here dot, and you can do the value count. So let's say value counts. So let's say value underscore counts, and then we can simply going to set one style. So let's set a style, and we can simply going to give it here a style. Let's call target, and then we can give it here the plt dot figure, and we can simply going to give it here on fixed size. So because this is nothing but on bar plot, so we can give it here 10,4 itself. So let's say sns dot bar plot, and we are going to give it here x is nothing but our gender dot index number, and the y is called genders dot values. Okay, it should be values, and then you can give it here plt dot show itself. अरे भाई क्या कर रहे हो पर ओके ओके सो एक्चुअली क्या ना वही क्या बोलती है इसको हिंदी में पता नहीं रैट्स इन इंग्लिश बहुत दिक्कत कर रहे हैं यहाँ पर okay, so you see that the female is the most, I mean he's the more than male. The female customer is more, okay, because in the mall female are going a lot because they are trying to buying some kind of face wash or some kind of things. That's why the female is obviously go to the market very well. uh, the male is nothing but busy for income source, busy for incoming something else like that. So that's why female is most in our data sets. Now what I can do, you simply going to cluster them, right? So we're gonna cluster them based on these two things: this annual income and spending score. Spending score is nothing but the how money they actually spend. Okay, so annual income and spending score. It's called a 2D clustering. Okay, you can also using here this 3D clustering as well. Let's first see that how can you do the 2D clusterings. So what I can do is simply going to cluster in the two features. So the spending score and the annual income. So we can using, let's say, data dot columns. So we're having those columns. So let's copy the data set. So let's say df is equal to data, and from data we're going to copy this out. So we're going to copy this out, and now it is stored it inside this variable df. Now let's try to store it inside x, and from the x I'm just taking here two things. One is the annual income, another one is spending scores. So I'm going to copy this out, and I'm going to copy this out. Okay, so that our data is not lost, our original data is not lost. So that's why just taking one copy of that. So we have the x and the df. Now we can simply going to see our x. So let's say x, okay, let's say x dot head, and then we can just have a do a scatter flow of the data set, because when you do the segmentation, we are segmenting to the based on the data points. So we're simply going to try to plotting here on a scatter plots. So we can using here, let's say, try to taking some shell as well. So let's say plt dot figure dot gigabyte figure, and then we're going to give it here the fixed size. So let's say fixed size, and then you can give it here, let's say 10,6, and after that let's throw on scatter plot because it is scatter data. So scatter plot, and inside that you can give it here one annual income. So while you actually try to do any segmentation tasks, make sure you just plotting the data set before, just for ensure that how your data look like. And in the y we're going to pass here the spending scores. So I'm going to copy this out, uh, Here you go, and I'm going to paste it to here. And then you can pass in here our data. So let's say data is nothing but our x. This is our x, and then you can give it here as equal to 60. And then you're simply going to give it here plt dot title, I mean sample of the 60, and then you're going to give it here the annual income. So let's say annual income. Let's say annual income, and in the, sorry, it should be the not title. Title should be the spending score versus, or annual income versus the spending score, like that. And in the x level, so let's say plt dot x level, we're going to give it to the x level of the annual income. So let's say plt dot y level, because we have the copy of the y level first. Then you're going to copy this out and it pass to here. And then you have the title, and you have this one, you can using here show. So okay, had not to be levels, should be level. So that's what data set, that how look like. And you can clearly see that we have one cluster, two cluster, three cluster, four cluster, and we have the five cluster, I think so. If I see, just have a see on that without using any machine learning problem. So it's just having the five cluster, you can see that. Now let's try to using here the machine learning algorithm in order to do the segmentation tasks. In just one single thing, we just see that we have the five clusters. Okay, just for ensurety, we don't know that how many cluster we have. So we can also calculate how many cluster we have using some elbow methods. So let's try to first importing here k-means clustering. So let's say Scikit-Learn dot cluster. I'm going to importing here the k-means. Okay, so let's say k-means. If you don't know what is the k-means clustering, you can just go on my AI concepts with coding from a scratch series. I already making some videos regarding the machine learning algorithm. So I also make the video regarding the k-means clustering. So you can just go and watch the video and try to implement the k-means clustering from scratch. Then you can understand what actually happening inside your data point, and how can you chose that how many k we need to choose using the elbow method formula. Now we calculate the within cluster sum of squared for different value of k, because in here we're to selecting here number of clusters. So next we need to choose the k for which WSS first to diminish. This k value give us the best number of cluster to make for the raw data. Okay, so we simply going to calculate it. Let's say for I in range, we can give it, let's say 1 comma 11. So in real kind of cases, your cluster is not going to go to the 20, go after 20. So you're just taking as a 1 to 11, but you clearly see that we may have the 5 clusters. So we can also ensure it by using here this WCSS method, or you can say elbow methods, or also called the inertia. So let's say km equal to, let's say k-means clustering, let's say call k-means, and inside there you can passing here the number of cluster. Let's give it here I, and then we have the km dot feed, and we're going to feed it to our x data. And after that, I'm going to storing here this WCSS inside a list. So let's say WCSS within cluster sum of squared. So we can using here WCSS dot append, and you're going to using here km dot inertia. So inertia is nothing but this WCSS. So let's enter, shift enter, and you can see it's actually executed. Now you can simply going to plotting this out. So what I can do is simply going to plotting the elbow method. This is called the elbow method. If you don't know what is this, just go and check out the videos of the description. I already linked this off about the k-means clustering. So let's say plt dot figure, okay, figure, and then you're going to using here fixed size, and then you're going to give it here figure. So let's say call 12 comma 6, and then I'm going to plot it. Let's say plt dot plot. So to give it here some kind of range. So our range is between the 1 to 11 that we give it to here, and then it passing here this WCSS value, I mean the data point, because this is a list itself. Now we can plot it. Let's say plt dot plot again. So we have the range of 1 comma 11, and you can passing here this WCSS, and let's say line width. So you can give it line width. So let's say di line width is equal to 2, and let's give it here on color. Let's give it here the red color. So that's the red color, and then you can give it here a marker. So give it here on marker. Let's give it here 8. Okay, this is the point for the markers. Now you can give it to the x level. So let's say x level, and then you can give it to the k value. So let's say k value, and in the y level we have the np dot arrange of 1 comma 11, and then you have the ones. So now let's add here the y level. Okay, so this is not a y level, it should be the x tick. So x tick, you can give it here x ticks, and in the y level we're going to give it here this wcss. Let's say wcss, and we can simply going to using a plt or show. So that's it, and you can see the elbow. So we see the elbow graph from 1 to 10 on here. So in here in the x-axis we have this wcss. I mean in the axis we have the wcss, and in the y-axis we have the in the y-axis we have the wcss, and in the x-axis we have the k values, I mean number of clusters. So the number of clusters taken at the elbow joint point, it's called the elbow joint point, you can see that. So the point is higher the making cluster is most relevant as the value of wcss suddenly stopped. See, suddenly stopped. Let's see, coming in this point is stopped, and then decreasing, and then stop decreasing. See, stop decreasing. So if I see that in here the quickly decreasing, but in from this 5, after 5 it's slowly decreasing, not at all. That's mean 5 is nothing but my number of clusters. 5 is nothing but my number of clusters. This is how we can actually initialize the number of clusters using these elbow methods. Now you can simply go into using here this one. So you can using here, let's say k-means. So let's say k-means, and inside this number of clusters we can simply going to pass it here the 5 clusters. So this is nothing but my model k-means clusters, and you can simply go into, let's say, km1 dot fit, and you can simply going to pass it to the x, and you can predict it. Let's say y equal to km1 dot predict, and you can simply going to passing here the x, and let's say df, we have the data right, and in our data we're going to give it here on another column called the level, and let's pass it to the y, and let's say df dot head. So you see that our data set is loaded. I mean our model is ready, and you also having one column called levels in here. So you can see that a column called levels. That's mean it will try to convert them in some kind of groups, or it will make them in kind of groups. Now you can simply go into plotting this group as well for the 2D data. I mean, because we're just taking here two features column, annual income and spending scores. So you can using here, let's say plt dot figure. So let's say plt dot figure, and inside that you can simply going to give it here, let's say fixed size, and then you're going to give it here, let's say 10 comma 6, and then we're going to do the scatter plot. It says sns dot scatter plot, and inside that you can give it here x is equal to, let's say, annual income. So I'm going to copy this out, annual income, and after that in the y we're going to pass in here these spending scores. So I'm going to copy this out, and then I'm going to give it to here spending scores, and then in the hue sections I'm going to pass in here my levels. So let's say level, and then I'm going to give it here some kind of palette, I mean color palette. So let's say PLE palettes, and let's give it here, let's say red color, and there's a green color, let's say orange color, and you can give it here the brown color, and then you can, let's say dot 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 blue, let's say legend. So you can give it here the legend. So we have the 5 color, right? So in the legend you can give it here the full. So let's say legend is equal to full, and then data is nothing but my df, and sample is nothing but the 60. For 60 sample, I can take this out. Now here you're going to using here X label, and then you're going to give it to here, let's say annual income. So in our x-axis we have the annual income, and the y label we have the spending score. Let's say pld dot y label, we have the spending score. And then in the title we can give it here, let's say pld dot title is nothing but the spending score versus, let's say, annual income, like that. So you can copy this out and you're going to pass it to here. That's the pld dot show. So pld dot show, and this cluster is nothing but for the 2D data. You can also use it for the ND data as well. So I'm going to show you that how can you do that. So you can see that we have the spending score versus the annual income. So we have the 5 cluster that you can see. Cluster number 1, cluster number 2, cluster number 3, cluster number 4, and the cluster number 5. So you can simply go into cluster them with a 2D. So you can also do it for the 3D or ND. So how the each of the cluster, I mean each of the customer is located to the each of the data point, it will uh, uh, classify them as these clusters. So let's say I have a data point is based on the green on here, on here, that's mean this data point is near to these clusters. Okay, and if the data point is near to this cluster, that's mean this data point is associated with these clusters. So this is how we can actually segmenting here the customers for the 2D. So let's say we have the and the features column. So how can you do that? Because you're just taking here this annual income and the spending score. Now what if I taking here the age as well? So what will be happen on these cases? So let's see. So also I write down a code just for checking the number of customer in the each of the group. So in our data set is just taking out the customer ID from here. So from the group number 1, I mean first group we have the 39 customers, and after the second group we have the 23. The third group we have the 35, and the fourth group we have the 22, and the fifth group we have the 81 customers. I mean just to segment them the data point based on that. So this is called the 2D segmentation or 2D clusterings. Now, what if I have the 3D data? I mean, if I have the 3D column, 3 columns. So let's take it, let's say df2. So let's say data, and from the data, we're simply going to taking here all of the columns. So it's better you can simply taking one shell, and then you can simply go into, let's say, data dot columns. So let's say columns. So we have those columns. You can copy this out, and you can also pass it to here. So this part is nothing but for the 3D. Okay, clustering on the basis of 3D data. Let's say clustering on the basis of 3D data. Okay, you can use it for the ND data as well. So let's go on the markdown and let's do the markdown here. So then we can using here, let's say df dot head. Okay, it should be df2 dot head. So how our data look like? That's what data is, how it will look like. Now from here we simply are taking here the 3 features. So let's say x is equal to df2. From df2 we're going to taking this one, and from the df2 taking here the age, the annual income, and the spending scores. So we simply going to taking this out, and let's try to make it as x. And then after that we need to calculate the WCSS. Same thing. Okay, same thing. So we can uh, copy this one. Okay, WCSS, I hope so this one. Yes, this one. So we're going to copy this out, and we can simply go into paste here on here. So just same thing, we need to pass in here this, we can make it the x2 as well if we want to don't miss passing the variable name. So x2, and in the number of cluster, you're going to pass in here the I, and as well as we're going to give it the init is equal to my k means clustering. So let's say k means, let's say k means plus plus, like that. So yeah, we append here the inertia as well as fitting here the x2 data, and we give it here some kind of range. So now our WCSS is also calculated. Now we can simply go into print, I mean plotting here or elbow data. So we can copy this out, and we can simply go into paste it to here. So we can paste it to here. So we have the WCSS, I mean this WCSS, and this W6 as well. So same thing, we have the same thing. After 5 it will it decreases, okay, because elbow point should be the same in the case of here, because data set is same as well. So you don't need to actually calculate the elbow point because you already got the point of the cluster is starting with the 5s. So in here you can also see that after 5 it will decreases automatically, but in from here it stopped decreasing, but after that it will decreasing slowly. That's when 5 is nothing but the number of clusters. So we can simply go into using here this k-means clustering. So we can copy this one, we can copy this one, and then you can give it here k-mean cluster number 2. So let's give it to here, let's say k-mean cluster number 2, and k-mean cluster number 2, and here should be the 2 as well. And then we don't need to predict it, or you can also predict it. Let's say it's a y2 and this is an y2 as well. So we can give it here levels, or also you can give it here, let's say df2 level, because it's a data frame number 2. So data frame number 2, and now we can simply going to enter. Okay, anything wrong, it should be the x2 as well. So it should be the x2. So that's our data. Let's see. So the features name should be matched those while passing you the feed. Features name unseen at first time ages. So I hope so. I need to run it again because it's already fitted, that's why. So camin number cluster, camin number 2, it should be 2. Yep, right now okay. Yep, right now okay. So you can see that we have our data set. It look like it also having one extra column called levels. Now you can simply going to do the floating. So for the floating, we are going to using here another library called actually uh, np float types for the axis 3D. So we need to also import it. So it's simply going to import it. Let's say from mpl toolkits. Let's say toolkits dot mp mp lot 3D. We're going to importing here the axis 3D. Let's say axis 3D, because you need to floating here the 3D float. So that's why. Now you can simply going to floating this out now. So we're going to simply go into taking some shell and let's say figure is equal to, let's say figure is equal to plt dot figure, and we are going to passing here, let's say fixed size, and then you give it, let's say 20 comma 10, and then it also give it here on an axis because we need to do the subplot. That's why let's say peak dot at subplot. So let's add underscore subplot. So inside that you're going to give it here, let's say 1 comma 111, and then in the projection you're going to give it here the 3D projection view, and then you can simply add it to the axis. So let's say scatter, and inside the scatter we're going to passing here, let's say df2 dot age. So taking the age, and inside this projections we're going to pass it here the level. If it is equal to 0th level, then you're going to printing this out. So let's say df 2 dot level is equal to 0. That's mean this cluster is associated with 0. And then you can using here, let's say df of annual income. So if the annual income, or you can also using a df2 dot like that. So df2 dot like that, and it is equal to the same 0. So let's say df2 dot level is equal to 0, and then same thing for the df2 of the spanning score. So let's say df2 of the spanning score. So expanding as a score, if it is equal to same 0, that's means it is passing to the 0th number cluster. So let's say df2 dot level is equal to 0. That's mean we just give it here some kind of colors. So we can give it here, let's say c equal to, let's say purple color. So let's say purple, purple, and then we can give it here some sample of the 16 data points. Now you're going to copy this out. We're going to copy this out, and just we're going to change the colors and the levels. So we're going to copy this out and to paste here the more 4 times. So 1 2 3 4, because we have the 5 clusters. So the purple, let's give it here to the red color, and it should be the, let's say, orange, and let's give it to the green, or let's give it to the yellow. Yellow is missing the previous times. So it should be the 1, it should be the 2, it should be the 3, it should be the 4. Same thing on here, it should be the 1, 2, 3, and the 4, as well as in here we have the 1, 2, 3, 4. So that's a 1, 2, 3, and the 4. So from the df2. Okay, so now we're simply going to plotting this out. So how can you do that? We can using here axis dot bu init. So let's say bu init, and inside there you can give it, let's say, 35 185 spanning scores, and then you're going to give it here x level, let's say x level, and then inside there you can give it here x level, let's say age is my x level, and the y level we have the annual income, and the z level we have the spending score. Because in the 3D you have 3 axes. In the x we're just adding here the ages, and in the y level we're going to passing here the annual income. Okay, should be the y level is nothing but the annual income, and in the case of z axis we're going to passing here the spending scores. So let's say axis dot set, okay, set z level, and inside that you're going to using here the spending scores. So we're going to using this one, spending scores, and here you go, and then you can give it here to using p-editor show. So let's see. So you can see that it's plotted in the 3D data. So we have the 5 clusters, we have the 5 clusters things. So you can see on here in the 3D plot. Okay, so how can you do the plotting? Now you can printing the customer ID actor to the group as well. So we can copy this thing, and we can copy this thing, and then you can paste it to here. So paste it to here, it should be the df2, df2, and df2, and df2, 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 and the df2, 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 df2. Okay, so now you can simply going to paste it here, or you can just make it as a 0. This is 0 cluster. You can make it as a 1, you can make it as a 2, you can make it as a 3, and you can make it as a 4. 0 1 2 3 4 like that, and then we can simply going to enter, shift enter. So for the first group we have the 77 clusters, and the second group we have the 25, and the third group we have the 39, in the fourth group we have 36, and the fifth group we have the 23 customers. So you can also do the 3D clustering as well, you can do the 2D clustering as well. So you can also use any of them to segmenting your clusters. So this is how this customer segmentation actually work in the case of k-means clusterings. So I hope so you like this video, and to share it, to subscribe my channel, so that you can get this kind of more interesting video about those kind of topic about the machine learning, deep learning, or AI. So thank you, and bye bye.